Okay, while this is figuring out, I can start by giving a shout out to my fellow co-authors. So I did this work with Lilia Slimani, who's now an apprentice lawyer in France, and Marie Arozin, who's a sociologist of the state, and its digital transformations. So this was the little team with which we started this project that revolves around the French housing benefits.
Can you plug it out and then plug it in again?
Okay. Up. Oh, extending the screen. Oh. Yes. See, it's closed.
It should work.
Okay, and it doesn't.
It's not populated.
Is it there?
We're receiving signals here.
That's the meaning of keynote.
No.
Oh, it's here.
Just PDF.
It's here, right?
Yeah,
This is the screen. Okay, so you just go here in person. It's been projected.
Okay, now it works.
Sorry for the delay.
Perfect. So, why did I choose the French housing benefits? Because it is a form of social benefit in France, which is quite widely distributed. We have more than 5.5 million beneficiaries, and the volume of money being given out is about 18 billion euros. It's the sedimentation of multiple reforms since World War II, which aimed at increasing access to affordable and decent housing. This act was created was France was half of it was destroyed after the war, and they wanted to incentivize people to build houses by giving money to the tenants who could more easily afford rent. But we also chose this benefit because it's one of the most difficult to compute. When you look at the rules that are defined in a body of legislative and regulatory sources, there are several formulas that are used to determine the exact amount of benefits, and it depends on the rent, and it depends also on the composition of the household, on the income, on the location of the housing, etc., etc. To give a precise amount of benefits that is enough for a tenant to ease the tenant's ability to pay his rent, but not too much because we don't want to give housing for free. It's not meant as a policy to give housing completely for free. So if you looked at the fact sheet of those benefits, there are 6 modes of computation, each one with a different formula that you have to take into account. And of course, there are tons of exceptional cases. The government released an explainer document that is meant to be an easy-to-use introduction to the computation of those benefits, which is already 80 pages long. And it doesn't contain the full diversity of roles that you need to take into account. These benefits are distributed by a government agency called the CAF, or I mean, if you're French, you all too well know that dreaded name. But it's operated by the national entity of the CAF, which is called the CNAF. And the CNAF has an IT system, which they call CRISTAL, that computes those benefits. The system dates from the 90s. So apparently they tried rewriting it in a proprietary technology that was presented at last year's ProLaLa' called the Oracle Intelligent Advisor. But I can't confirm that this is the stuff that they actually use. What I know is that the old CRISTAL system, I know that they use. So the objective of this study around the housing benefits was to study the source code and understand how the regulation that is specified is written and how that the two are synced together, who is responsible and how they do it concretely to check that the regulation that describes the amount of benefits that should be awarded is correct with respect to how the program is correct with respect to those regulations. So the first thing that we ought to do is to simply look at the source code, right? The problem is that this CRISTAL source code is written in COBOL, plus it's surely been written with a computer-aided software engineering tool. So it's like a kind of an IDE for COBOL. It's like it was very much in fashion in the 90s. The problem is that they only published the generated code, so when you try to read it, it's unreadable. So it's quite useless. And of course, they distribute the source code with a CD-ROM. So this was from 2020. So unfortunately, we couldn't use that to assess the correctness of the program. So we decided to simulate what the CNAF is doing by replicating the production of the source code. And we did it in Catala, which is the language that you've already seen presented in this workshop. So if you crunch the numbers, we collected all the regulatory legal sources that describe the computation, which is about 100 pages. We wrote about 7,000 lines of computer code. If you weave all the computer code and the documents together, it amounts to almost 300 pages. We did this programming in about 50 hours of lawyer programmer pair programming sessions. And we had to add like 120 hours of legal research and debugging and writing tests, etc., etc. So all in all, it represents to about 1.5 to 2 man-months of cumulated work on this implementation, which is a lot, but not absurdly a lot, which means that it actually could be envisioned for something for generalizing this method to all other benefits. And so this is a little session of a little snapshot of how we did. So we just presented the code on the screen, and the lawyer was on the left, I was on the right, and we just coded up the thing. Most of the time was actually spent in deciphering the text of the regulations because they were very hard to read and very hard to understand. I don't know the comparison with FISA, but it's the kind of text that you read first, twice, thrice, then you don't understand. Then you reread two articles then, and then you come back to it. Then it's been an hour and you haven't started programming. It's just about understanding the meaning. And we've done all of that very much in sync with the methodology we've set out for the use of the programming language Catala, which is about literate programming to effectively implement that old idea in legal informatics that is called isomorphism. We do pair programming because we believe that we can't wait for a lawyer to go through CS school or the converse and we think that intense transdisciplinary discussion can also lead to a mutual comprehension and enabling the effective check of correctness of the code and an efficient production and maintenance of the code that is supposed to simulate to implement legislative or regulatory specifications. And of course, we're in public research, so the code is open source, but also think that this open sourceness is critical if we want everybody that's concerned to be able to check or contest the decisions, interpretative decisions that we've made when we did the source code. So the code is available, it's on the Catala GitHub repo. It's under examples, you can see what it looks like. Okay, so that was for the context of the study. We discovered some legal challenges, but also some language design challenge. I know that you're all excited for language design challenges, but I want to start with a legal challenge and one that is very, very much math oriented. And the challenge happens when imagine that you have some children, and of course the more children you have, the more housing benefits you're supposed to have, because the more children you have, the bigger the housing you should have, so the more money you should have to pay for it. That's the spirit. But what happens if one or more of the children sits in split custody? Well, then you shouldn't have all the portion of the benefits that is for this children. You should only have half of it. So how do you determine what's the portion of the benefits? Because the formula is not as simple as, okay, you get the base benefits and then you get a bonus for each children. The formula is highly nonlinear, and the children are taken into account at multiple parts of the formula. So the way in which you should perform that division is the following. You suppose that you have this graph where the green line is the stylized computing computation of housing benefits depending on the number of children you have in your household. So what you're going to do is that you're going to consider how much money you would have without any of the children in split custody, and how much money you would have if all the children in split custody would be full custody. And then you're going to take the mean household. And then this mean household is what you want to approximate, and this is the thing that you want to have. So, but sometimes, so I put the whole green curve here, but the curve is actually only defined at integer points of children. So if the mean household falls into like a non-integer number of children, then you have to approximate. So you can do a linear approximation between the 2 points. So that would be a standard thing. The problem is that the CNAF doesn't do that. And the CNAF doesn't do that because they have technical constraints, which is that they can only compute point B and they can't compute point A. Because they can't recompute the benefits twice for the same household. We don't know for sure why they can't do that, but we think it's linked to the fact that it's written in COBOL, and that in COBOL, functions are not really a thing, it's more like a procedure thing, but then procedure can have global mutable states that prevents its calling twice as a regular function. So since they can't compute A, but they have to produce a result, they thought of just, instead of taking A, taking the origin point O. And it gives the point C of housing benefits to distribute. But you may have looked, because the function of housing benefits with respect to the number of children is concave, point C is below point D, which means that people would receive less money with this approximation than what they would normally have been entitled to. And this is a problem. So why? But so far the CNAF doesn't do any of it. But why do I know that they consider this approximation? It's because they've already done that approximation for another kind of benefit, the family benefits. And at that point it worked because the function is convex, so point C is above point D, so they give more money to people than what they should be normally entitled to, but that's fine because giving more money to people that need it is not a problem. But they can't replicate that trick here, so they're kind of stuck, and it's been 5 years. There's a court decision that mandates that they split those benefits, and they don't do it, except when people complain, especially citing the court decision, and then they do it by hand. which is not a happy situation. But you can see here that the technical limitations of the computer program that computes the benefit has legal repercussion because the CNAF is now operating kind of in an illegal situation, although if you complain, they will do the legal thing. So these are things to be taken into account. And I've written that in a report and communicated that to them, but I haven't heard any answer so far. We'll see if they take it into account. So that was for the legal challenges, and we've written up all of the others that we found in a companion paper that you can consult. It's called Rule Computations and Benefits, Scrutinizing Programming Choices in French Housing Benefits. But for the rest of the presentation, I want to focus more specifically on the language design challenges that we've encountered while we're producing this somewhat medium-sized code base. And how they've been tackled in Catala, and was Catala enough for this thing? So first aspect is talk about the feasibility. So it's been a widely commented point on the literature, but for this program, we didn't need fully fledged feasibility. We can only go and implement the whole thing with a tree-like exception structure. So I'll take an example with the rental charges computation. So have base case, and then if you're flat sharing, it's an exception to the base case, but then if you're overseas, it's an exception to both the base case and the flat sharing in the base case, so it's also an exception to the flat sharing. If you're overseas and flat sharing, then it's an exception to everything else. And in all of these blocks, there are several definitions that coexist together, one per year. So this actually forms like some kind of a tree. That's okay, and we have a mechanism to model this tree-like exception structure in Catala, where you just define like so you put labels on all the definitions that go into the same group, and then you declare the parent-child relationship in the graph by putting these exception keywords. And that seems to be sufficient. And so these results experimentally show that although you need some kind of diffusibility, because if you didn't have that, it would be very complicated to write that with a series of if analyses. You don't need that fully fledged diffusibility. You only need, so what Sarah Lowski had already identified in her papers, which is the prioritized default logic. Yeah, I refer to the papers for more precisions. Another language design challenge, which I don't hear a lot, and I haven't heard so far in ProLaLa', is the precision of the computation. Because here we're computing an amount of euros that has to be in and out, and this amount of euros actually depends on how do you do the rounding at every intermediate step of the computation. And there are rounding rules in the regulations that says that, oh, you have to compute that amount and round it to the second or third decimal. So that's fine, this is not ambiguous, we can model that. But if you look at that formula, which is kind of an aggregation of an application of brackets to an amount of income, and then the bracket limits are multiplied by a coefficient at some point, and then you add a lump sum multiplied by another thing. So this is kind of a large formula with multiplications and additions. If you round every amount of money to the nearest cent after each sub-expression, you will get a different result than if you treat this whole computation as an infinite precision arithmetic, and then you round at the end. And so we had to ask the question to the office, administrative office that was writing the regulations, because in their official explainer document they would explain by rounding to the nearest cent. But then we asked them, is this the true behavior? And then we said, no, the way we explain it is not the correct way, you have to compute it. The computation has to be done with all the numbers. But we thought it weird, because if you can't explain what the correct behavior would be, it's kind of difficult, right, to have that as an official explanation. So we complied with what the administrative office said, and we said, okay, we're going to switch the types of the pieces of data we manipulate in Catala and insert explicit casts to know when we're rounding and when we're not rounding. And in Catala we do computations with infinite precision by default. And we round the amount of money to the nearest cent, and we don't use floats, and I implore you never to use floats when you deal with money. But I mean, you already know that, but I re-say it. Especially if you're in a tax office, never use floats. Okay. Another language design challenge is the use of functions. And I think this is somewhat overlooked, the need for functions, not just non-interpreted functions like you could do when encoded in first-order logic, but actually interpreted functions, because as you've seen in the split custody example, you need to compute the benefits twice, one for two different and related households. And this is a pattern that comes a lot in tax and social benefits law. In French, they even have a name for that. They call that multiple liquidations. And that's how they say in like fiscal jargon. And we did actually experience that having real first-class functions in the language was an asset. Also, not to duplicate computations. For instance, there are different modes of computation for the housing benefits, one for the rental, one for the communal housing, and one for the home ownership cases. And if we split those into 3 different functions, we can match over the situation and call just this function we need, instead of computing 3 different cases all the time with dummy values and just select at the end with the value we need. This is something that if you start to go into real-world, medium-sized programs, you'll find a lot. And so we found that having functions is useful. So of course, if you have functions, we say, okay, can we have higher order functions, because we like lambda calculus. So Catala supports a limited form of higher order functions, which is not crazily useful. You can do without them, but we found an example where they're kind of useful. It's also about the split custodies thing. It's really split custodies. It's really a nightmare to implement, but you have to do it. So the amount of housing benefits, it's really a series of post-treatment steps applied to an amount that you extract from a base formula. And when you do the split custody correction, you should only do it to the base formula and then apply the post-treatment steps after you've done the correction for split custodies. But the problem is that the post-treatment steps depend on which sector you're in. The post-treatment for rental is different from the post-treatment steps for home ownership and the communal housing thing. So the way we did that is that we have this comp with split and comp without split, which are the functions that return two things. They return the base formula amount, but also the post-treatment steps as a higher order function. And then we can use the return function to just apply it. And this saves us the worry of having to repeat the code. I mean, you could encode it in a different way, but this is just kind of a little bit elegant and concise way to do it with higher order. So just for the end, I want to briefly show what the demo of this looks like. So we compiled the Catala code to JavaScript, which is one of the languages that we support with the Catala compiler. And then I've meticulously taken all the input fields that we asked, and I've looked at what is the legislative article that requires this input piece of data to be present. And then this is all compiled down into this form, which is way more complete than the form that the CNAF asks, because the CNAF, for instance, they prefer to decide what people, the situation where people are based on proxy data that they collect from other sources, than to have people declare what their situation is. For instance, in the CNAF, you can't declare whether you're flat sharing or not. The CAF decides it for you. But sometimes they decide it for you and it's not your real situation, so you have to complain, and then you don't have any benefits for 3 months until they process your complaints, which poses some problems. So this is not the case here. We let the people declare everything. And at the end you have this, amount that you're, so this is, people actually receive several hundreds of euros in benefits. This is not uncommon. And then you can see that the code is evolving, because as time goes by and some parameters are indexed on inflation, they regularly issue reindexations of the parameters. So if you go further in time, the amount increases a little bit. But of course, you can also play with all these other parameters. And then you have a little explainer thing, which I'm not going to show to you, but this basically shows the call tree. If you click multiple times on the arrows and stuff, it will show to you the call tree and all the individual definitions of variable along to where in the source code and in the legislative sources it has been defined. Okay, so the key takeaways is that when we've done this study and the real world text example, we discovered that so legal texts are ambiguous and they can contain mistakes, but this is not a new result. But we've also shown how technical constraints can shape the computation and the legal texts that are taken to specify those computations. In terms of language design challenges, we've roughly found that the ingredients that you need for formalizing tax and benefits law, which are unilateral decisions taken by the administration, so you don't have to formalize like a dialogue between participants. You mostly need some form of limited form of divisibility. You need precision in your computation. You need functions, and you also need some kind of modularity to organize the code, because when you're reaching 7,000 lines of code, you need to organize it somehow. So whether it be like functions can be a way of organizing the code, but also modules, namespaces, structs and enums, of course, because you want to organize also your input data and your data structures. So my email address it's email.fr, but you can contact me or have a chat with me if you want more details or anecdotes about the CNAF, and I'm ready to answer some questions.
Thank you a lot.
Denis,
You have a question?
Thank you very much.
practice of pair programming as I think about taking this study more broadly. Pair programs, I understand, usually practice to get some of the benefits requires being able to swap who's at the keyboard. The benefits of getting instant code review seems like it depends on having somebody to understand it. How do you find code review to be an effective practice without two programmers? And I guess the reverse question, how does the programmer check the understanding of the law?
Thank you for your question. Indeed, if you have one programmer and a lawyer, you don't get the benefits of swapping programmers with the pair programming. So that we don't get. Of course, you can have 3 people and then swap the programmers, but then it becomes more and more costly. The benefit that we do have is the instant code review, and this actually works because so you can do asynchronous code review, but then the amount and the intensity of the discussion we have during the session, if we were to write it all down and do it asynchronously, it would be so much more complicated and it would take so much more time. Of course, we note down the decisions that we take. For instance, we can chat for 30 minutes about how we should interpret an article, and then after we take a decision. But then we note the decision and why the main motivation points and why we took the decision. But the pair programming really allows and the lawyer, and sometimes the programmer doesn't understand the law, and then the lawyer would spend like 20 minutes explaining what's the purpose of the law to the programmer, and conversely, sometimes the lawyer wouldn't understand the program, and then the programmer would explain during 30 minutes, or what does it mean to have an enum, or what is a function, or what does it mean to round things, or all the little semantic features, and at the end, the two build a mutual understanding, and it goes faster and faster. But then it's a matter of vigilance also, because at the end, if the two don't discuss and they just take what the other is writing or checking for granted, then the vigilance is slows down, and then you're not doing the review correctly. But this is a problem of a classical problem. Yeah.
I mean, we had a lot of questions. We probably take them over lunch and then go forward to the next year. But let's thank Denis again. Wonderful talk.